Hi class, in this video we're going to be using the constant of proportionality and a variety of other methods to determine which ratios are going to be equivalent. So first things first, let's define what the constant of proportionality was. So let's say I have a ratio where it's A to B. The constant of proportionality is going to be represented with letter K. It's going to state that A equals to K times B. All right. And what I'm going to do is I can divide both the right side and the left side by b. So hence k is going to equal to a over b. So what that means is if I have a ratio a to b, all I do is take a, put it as my numerator, and take b, place it as my denominator, and then k equals to a over b. So what I'm going to do here for my first example, 3:5 or 3 to 5, my constant of proportionality would just be 3 over 5. And now for this ratio here, 18 to 30, if I end up getting the same constant of proportionality, then they are equivalent. So in this case here, for 18 to 30, I'm going to have 18 over 30. And once I have 18 over 30, I can reduce this fraction. So I can divide both top and bottom by 2. And if I do that, I'm now going to get 6 over 15. And for 6 over 15, I can reduce it some more by dividing top and bottom by 3. And if I do that, I'm now going to get 3 over 5 as my final answer that can't be reduced anymore. So hence, because they have the same constant of proportionality, where k equals to 3 over 5 or 0.6, you can say these are equivalent. So I'm going to say A has equivalent ratios. Okay, now for B, I have 4 to 9. So again, for 4 to 9, my constant of proportionality would just be 4 over 9. And now for 12 to 28, my constant of proportionality will be 12 over 28. So let's try to reduce 12 divided by 28. So I'm going to divide both the top number and the bottom number by 2. So now that's going to get me 6 over 14. And I'm going to once again divide both the top and bottom number by 2. So that's now going to get me 3 over 7. And because 3 and 7 are prime numbers, I can't reduce any further. Since the constant of proportionalities are not the same, I can say that B does not have equivalent ratios. Okay, now there's also another way to determine if they are equivalent or not. If I had just these ratios here, what I'm going to do is this. On the left side, I'm going to ask myself, what can I multiply 3 by to get to 18? And the answer would be 6. 3 times 6 is 18. But what I do to the left side, I have to do to the right side. So 5 times 6 is also going to be 30. And because I can multiply both the left side and the right side by the same number, these are equivalent ratios. So I can say these are equivalent ratios. Now for B, I'm going to ask myself the same question again. What can I multiply the left side by in order to get 12? And in this case, 4 times 3 is going to get me 12. However, what I do to the left side, I have to do to the right side. But if I do 9 times 3 here, well, that wouldn't really work, right? Because technically speaking, 9 times 3 equals to 27. 9 times 3 does not equal to 28. So hence, for B, I do not have equivalent ratios. So that's the other way we can solve to see if ratios are equivalent or not. Now, back to the method of using the constant of proportionality, we're going to move on to our third example here. For C, I have a three-term ratio now. So it's going to be 2 to 5 to 10, and I'm going to compare it to 18 to 45 to 90. So for a three-term, you just want to compare the ratios from left to right and just compare the first two first. So from 2 to 5, I'm going to have 2 over 5. And from 5 to 10, I'm going to have 5 over 10. Okay, great. Okay, great. And now I'm going to have 18 over 45. And then I'm going to have 45 over 90. Okay, now here's what I do notice. For the 18 over 45, I can divide both the top and bottom by 9. And if I do that, I'm now going to get 2 over 5. So great. One of these two are equivalent. Now, for 5 over 10, well, technically I can reduce this by dividing both top and bottom by 5. That will now get me 1/2. But for 45 over 90, I can also divide both top and bottom by 45. So that would also get me 1/2. Since now I have 1/2 and 1/2, 2 over 5 and 2 over 5, I can say, based off of the constant of proportionality here, so in both cases here, the constant of proportionality is 1/2. And in both cases here, here and here, the constant of proportionality is 2 over 5. I can say that these are going to be equivalent. So hence for C, I'm going to have equivalent ratios. Now, if I were to solve this using the other method, what I'll do is this. So I have to ask myself, what number can I multiply 2 by in order to get to 18? And in this case, 2 times 9 gets me 18. And can I also multiply 5 by 9 to get to 45? And in this case, 5 times 9 is 45. Now I ask myself this last question. Can I multiply 10 by 9 to get to 90? And in this case, that's also a yes. So if I can multiply every number by the same number and get to these exact results, then that means for C, I do have equivalent ratios. So now back to our original method of solving this using the constant of proportionality. So hopefully that gives you an idea with regards to how to figure out if ratios are equivalent.